Hi, everyone. In this video, I will be giving an example of moderated mediation using process model 58 in RStudio. So we will be using Hayes process macro to carry out our analysis. So before I get started, I do want to mention that underneath the video description, you'll find a link to a CSV file that contains the data that we'll be working from during this analysis. So you can, or during this demonstration, so you can download a copy of the data to follow along. You'll also find a link to another source that provides some additional details that you might find useful as kind of a supplement or addition to what I'm talking about in the video. So be sure to check that out as well. So let's go ahead and get started just by looking at process model 58. So here is a conceptual diagram of process model 58. So it contains the traditional mediation triangle, but with the addition of a moderating variable. So just kind of going through our model right here, the mediation triangle, we have variable x, which is our antecedent, variable m, our mediator, and our consequent is variable y. So you'll see that we have an arrow pointing from the antecedent to the mediator. We'll denote that as path A. Then we have an arrow pointing from the mediator to the consequent. That is path B. And then we have an arrow from the antecedent to the consequent. We'll denote as path C prime. So each of those paths are direct effects within the model, are proposed effects of one variable on another in the model. And again, we have paths A, B, and C prime path. So the effect of the antecedent x on y can actually be broken down into two components. The total effect of the antecedent on or x on y can be broken down into an indirect effect by way of the effect of the antecedent on the mediator and the effect of the mediator on the consequent, and a direct effect. The indirect effect is computed as a product of paths A and B, and the direct effect is essentially C prime right here. So in the traditional mediation triangle, again, we can break down the total effect of x on y into an indirect effect and a direct effect. Now, in this model, you can see that we have a moderating variable w, and we have arrows that are pointing from the moderator to paths A and B. So in the standard mediation triangle without the moderator, our expectation would be that there's only one estimate for path A and path B right there, and obviously for path C prime, but we're not really focusing in on that in this discussion. When we incorporate a moderating variable where we have these arrows kind of drawn to those other arrows, the idea is that the effect of the antecedent on the mediator is not constant, but rather it varies across levels of the moderator. Or in other words, it depends on the level of the moderator. So instead of having a single value for A or for path A, there's actually a value for path A at different levels of the moderating variable. The same logic then applies when we're talking about path B right there, that there's not a single estimate for path B, but rather the effect of the mediator on the consequent varies across levels of the moderator. That also means by extension that the indirect effect that we had computed previously is not just a single value, but instead would vary across levels of the moderator. So there would be a different indirect effect that would be computed per level of the moderating variable. Now, in terms of the estimates within our model, when we're running our analysis using the process macro, basically it's using least squares regression to estimate our various path coefficients. And so you can see right here, this is just a breakdown of the two linear regressions that are used to compute the path coefficients that would be that we're talking about in the context of this conceptual diagram right here. So as you can see right here, we have in the first model, we have variable x, we have variable w, and then we have the interaction between x and w. All of those are predicting the mediating variable right here. So the effect of x on m because we are including W in the interaction term, and mainly it's the interaction term, then what's happening is that we are essentially saying that this effect right here varies across levels of the moderating variable. Then when we look at our second model, we have X, we have M, we have W, and then we have the product of the mediator and the moderating variable. So in this particular case, the effect of the mediator on Y, because we're including our interaction term right here, we're essentially stating that the effect of the mediator on Y varies across levels of the moderator, W. Okay, so now let's transition into our example and talk a little bit about the data and so forth. And then we'll move into opening up RStudio and running our analysis. So the data that we're working with is coming from this article right here. This was found at the Frontiers in Psychology website. The article was published in 2022. It's the effect of trait mindfulness on social media rumination, upward social comparison as a moderated mediator. And so basically the authors include a copy of their data at this website. So I was able to download it, and actually I saved it under a new file name that again is the one that that you would be downloading underneath the video description. Now, this is the model that the authors were testing. In this model, they had trait mindfulness serving as the antecedent, upward social comparison serving as the mediator, social media rumination serving as the outcome variable or the consequent, with self-esteem serving as the proposed moderator. You'll see they have an arrow drawn from covariates to social media rumination. Technically speaking, when you're running model 58, if you include covariates, the covariates will be not only be included as predictors of social media rumination, but also social media or the upward social comparison. So this is actually probably a better way of looking at that particular model, where I have covariates arrows drawn to upward social comparison and social media rumination. Now, before we actually begin running our analysis, I do think it's kind of important to note that when I ran the analysis, some of the results that I got were at odds or differed from some of the results that the authors reported on in their text and in their tables. I had to kind of do a little bit of investigating, but it seems like the source of the problem lies with the control variables or the covariates that they were including in their model. So when I was generating the correlations and descriptive statistics for trait mindfulness, upward social comparison, social media rumination, self-esteem, all that looked good. But the correlations involving the covariates and amongst themselves and then some of these other variables, they were not the same as what I generated. So what you see in some of their tables will look a little bit different. I don't know if there's a data error or some kind of problem like that with the file that they uploaded. I'm not exactly sure. The main objective of this discussion is mainly pedagogical anyway, to show you how to run Model 58. But I did want you to be aware, in case you went back and you read the article and you wanted to compare results, that this would be a source of discrepancy between what you will likely generate on your own and what the authors reported. So just kind of be mindful of that. Okay, so here I've opened up RStudio, and you'll see on your screen right here in this script on the left, right over here, this window, this is the script file for the process macros. So essentially, when you download the R macro from the website, you'll see that when you open it up, it's a zip file. When you open it up, there are three versions of the macro. There's a SAS version, SPSS version, and an R version. So if you click on the R version, it'll open up in RStudio like this, and you can basically use it from there. It is important to kind of mention that before you can use any of the syntax associated with the process macro, you have to activate the macro first. So right now I've not activated the macro. I'm going to go ahead and do that, and then we'll proceed. So I'm going to right click in this box right here, click on select all, and then click on run. And you can see down below, you can see the macro is being activated. So it takes a little bit of time to get it going. So just be patient. It'll stop in a second, and then we'll go through importing our data and then running the analysis. Okay, so now it stopped running. You can see down at the bottom it says process is ready for use. So now we can actually run our analysis. I'm going to go ahead and click on File, go to New File. We'll open up a new script editor right here. And I need to import the data first. So we're going to go to Session, Set Working Directory, choose Directory, and basically find the folder on your computer where the data is located. This is the location. Oh, excuse me. All right, this is actually the location. It actually previously took me to a temp file, but this is the location on my computer where the data is saved. So I'm going to click on Open, and you'll see down at the bottom it says Set Working Directory. This is just the function for setting the working directory, and that's been accomplished. So now we'll import the data. We're going to go to File, Import Dataset from Text Base right here. And this is it right here. So we're going to click on that and click on Open right here. And you'll see that there's a little preview window down here. You can see that you got V1, V2, V3, all those are in the first row. And then you got the names of the variables in the second row. So make sure that you click heading right here and have this set to yes, and that then puts the names of our variables in the first row. And so if we scroll across, you can see all the variables in the data set. The main variables that we are analyzing are actually found at the end of the data set. So the variables include gender, age, usage, education. Those are actually the control variables or the covariates in the model. And then you've got the main variables, which are mindfulness, USC, which is upward social comparison, rumination, and SE is self-esteem or self-efficacy. So we'll click on the import button, and there you go. So now you can see our data set right there as well. So the data, when it was imported, it was saved as a data frame. That's it that you see above. So it's trait mind underscore ORIG underscore data. And by the way, I think I referred to self-efficacy previously with SE. It's actually self-esteem. So we'll go ahead and go back to our script editor, and the function that we're going to be using to run our analysis is the process function. So inside our parentheses here, we will go ahead and start off with the data argument. We'll set this equal to the name of our data frame, which is trait mind underscore ORIG underscore data, then comma, and then we're going to specify our consequent. So we type in y equals, and inside quotation marks, we refer to the variable in our data set that is our consequent, which is rumination. Okay, make sure that that is in quotation marks. Then we're going to refer to our antecedent, which is x. So we'll type in x equals, and in quotation marks, mindfulness, in quotation marks, then comma. And then we will refer to our mediator. So we'll type in m equals, and then in quotation marks, capital USC. Okay, if it happened to be the case where you had multiple mediators, by the way, then you would have to use the CList function in order to specify a list of mediators. So then we'll type in comma and then W, and we'll set this equal to SE, both of those are in quotation marks, for self-esteem, and then comma, and then we're going to use the COV argument. So this is for covariates. If you don't have any covariates, you don't need to include this argument. So we'll set this equal to the names of our covariates in the model, and because we have multiple covariates, we'll use the C listing function right here. So we'll type C, and inside parentheses we're going to type in the names of our covariates, enclosed in quotation marks and separated by commas. So we'll type in gender, then age, then education, and then usage right there. And then we'll have our in parenthesis and then comma, and then we're going to go to our next argument, which is center. So, and we're going to set this equal to 2. So the center argument specifies how we want to, whether we want to mean center our variables that are used in the construction of the products for inclusion in our models, or whether we want to center them or not center them, and then if we want to center them, how we want to center them. So basically the 2 right here just means that if we are creating a product variable out of 2 continuous variables, it's going to center those 2 variables. But if it happened to be the case where one of the variables was a binary variable, then it would only mean center the continuous variable. So the 2 just means mean center all continuous variables that are used in the construction of a product. If you set it equal to 1, then it would be instructing process to mean center all variables, irrespective of whether they are all variables included in the construction of a product, irrespective of whether they are continuous or binary. So we'll type a comma right here. We're going to specify model equals 58. So make sure that you specify your model number. So it's 58, then comma, and then we'll type in seed right here. And we're going to set this equal to 1, 2, 3, 4, 5. Basically, the seed is most useful for reproducing your results, the bootstrap results. So if I have the same data set and I analyze the data tomorrow, if I use the same seed number, then the confidence intervals, the bootstrap confidence intervals should be the same. So the seed is just a number that, if I reanalyze the same data tomorrow or next week, if I use the same seed number, then I should end up with exactly the same results from the bootstrapped outcomes. So then we're going to type in int probe and set this equal to 0.20. So int probe, this is interaction probe. Basically, if we find, like for let's say regression model 1, let's say the interaction is a term, we have a p-value that is 0.20 or less. So if I have this set at 0.20, then what will happen is it will generate simple slopes and associated tests. So basically allowing you to perform simple slopes analysis. I could easily set this more conservatively at 0.05 and just say I want simple slopes only if the interaction is significant at 0.05. But we're just going to be kind of conservative right here. We'll set it at 0.20. And the same would go for the interaction term in that second regression model. So the interaction probe is essentially, that argument is allowing you to specify a threshold for including simple slopes and significance tests for those slopes in your output. So next we'll type in comma and set an argument or include the argument plot. We'll set this equal to 1. So the plotting function allows you to plot out simple slopes. So basically it's going to, if we include this, we're going to get a table back that includes 3 values, essentially 3 variables, but one is representing the focal antecedent, then the moderator, and then predicted values on the consequent. And essentially what we can do is we can plot out the interaction. So just keep in mind, though, that process will not generate a plot automatically. We'll have to generate that using the information that's contained in that table, and I'll show you how to do that in a bit. Then we'll add a comma, and I'm going to include the moments argument right here. And I'm going to set this equal to 0. So what this really has to do with is the conditioning values of the moderator. So if we want to test simple slopes and we want to generate a plot of those simple slopes, we have a couple of options with process. One option is to use the conditioning values of the 16th, 50th, and 84th percentiles of the moderator variable, or use the more traditional pick a point approach of -1 standard deviation mean and +1 standard deviation from the mean as those conditioning values. So if I set moments equal to 0, we're requesting the 16th, 50th, and 84th percentiles. Or if we just leave that out altogether, it defaults by giving you that. And that's actually Hayes' preferred approach when it comes to selecting conditioning values for the moderator. If we set this equal to 1, though, then that will get us the conditioning values at -1 standard deviation from the mean, and +1 standard deviations from the mean. Okay, then next we'll add a comma. We have a progress argument right here, and we're going to set this equal to 0. Basically, this just has to do with the giving you sort of a indication of the progress, bootstrapping progress. And so the little counter, I mean, there's nothing wrong with it. There's nothing problematic. It just may be a little bit aggravating to have in your output because it'll have a long counter where it will kind of count through all of the bootstrap samples and so forth. If you set this equal to 0, then it will prevent that counter from appearing. If you set it equal to 1, then it will be generated. Or if you just leave that argument out altogether, it will be generated. Then finally, we're going to use the contrast option right here. We're going to set this equal to 1. So the reason why we're including this particular option is that when you are running other types of moderated mediation models, where let's say, for instance, you're running model 7, where you have essentially path A is the only path being moderated by variable W, the moderating variable. In that particular case, then what part of the output would include an index of moderated mediation. So that index of moderated mediation, there'll be a confidence interval that's generated, a bootstrap confidence interval, and you can use that confidence interval to test whether there is evidence of moderated mediation that's occurring. The same would go if you're using model 8, which is still referring, you'd still be talking about path A, or if you're talking about models 14 and 15, where you would be dealing with just path B. So in the current analysis, though, we have both paths A and B being moderated, and so essentially there's no way to compute the index of moderated mediation as you have in the context of those other analyses. And the reason why is because in those other analyses, the indirect effect is being modeled as a linear function of the moderator. In the context where you have paths A and B both being moderated by W, then the indirect effect is not a linear function of W, but rather it's a nonlinear function. And so we can't compute the linear index of moderated mediation as a result. So process is not going to generate that for you. And so you have to kind of think about other options when you're trying to evaluate whether there is evidence of moderated mediation. So Hayes and Rockwood in their article in 2020 suggests using contrast in order to do that. So basically contrasting indirect effects between different conditioning values of your moderator variable. So I've set contrast equal to 1 in order to accomplish that. So now I think we are ready to go. We'll highlight all of this and click on run. And so it takes a few seconds because it's performing the bootstrapping. You can see the little stop sign still lit up. Now it's stopped. And so the bootstrapping is all done. And we have our output. So you can see in our output, the first model, which you can see the outcome variable is USC right here. So that's the upward social comparison. So with this model, the output contains regression output. So you can see that we've got the R-square value for that model. So that's the variance accounted for by the set of the predictor variables, or proportion of variance accounted for. You can see that you've got your F statistic, you've got your degrees of freedom associated with the analysis, and then you got your p-value that's given right there. If you keep in mind that first model, we were looking at the effect of mindfulness on upward social comparison as moderated by self-esteem. So there's self-esteem right there. And then we've got this interaction term that's given right here. So the effect that you see right here, this is the effect of mindfulness on upward social comparison when self-esteem is at 0. So that's essentially a simple conditional effect right there. Then we have the interaction term, the regression slope for the interaction term of 0.1894 right there. And you can see that it is statistically significant. So what that's telling us is that, this right here, this slope that you see right here, this is the effect of mindfulness on upward social comparison when self-esteem is equal to 0, but that's only 1 point. So this slope right here is telling us about the change in the slopes per unit increase on self-esteem. So this right here is basically indicating whether or not there's a change in the slope, and then we have the p-value that's given over here, and if that's significant, that tells us then that there's variation in the slope for the effect of mindfulness on upward social comparison. So we have evidence of moderation for path A in this part of our output. Now, if we scroll down, you can see that we get the conditional effects of the focal predictor at values of the moderator. So recall that we had set our interaction probe equal to 0.20. So because our p-value for the interaction term was obviously well below 0.20, then this information is generated right here. This is the conditional effects. And so remember too that we had specified the set the moments argument basically equal to 0, and that's going to generate the 16th, 50th, and 84th percentiles for self-esteem over here. So these are those percentiles for self-esteem, and then you've got the effects at each of those levels. So there's the effect at the 16th percentile, at the 50th percentile, and then at the 84th percentile. And you can see that these numbers are becoming less negative, or you could say increasingly positive, and that's reflected in this positive coefficient for the interaction term. So we also see that we have t-tests for each of those simple effects. So you can see, again, the simple effect at the 16th percentile for self-esteem is negative 0.5869. You can see that that is statistically significant. At negative 0.3344, that is significant. That's at the 50th percentile for self-esteem. And then at the 84th percentile, the slope is negative 0.145, and that is not statistically significant. But just keep in mind that the conditional effects themselves, looking at each individual effect, that's not really an indicator of moderation. What is an indicator of moderation is the change in the effects across levels of the moderator, and it's quantified in our regression results in the regression coefficient for our interaction term. You also see down below that we've got data for visualizing the conditional effect of the focal predictor. So this is what I was talking about when we use the plot option. So we have mindfulness, and you can see that we have 3 values represented. We have 16th, 50th, and 84th percentiles for mindfulness. And then for self-esteem, we have the 16th, 50th, and 84th percentiles. And then we have the predicted values for upward social comparison at each combination of those percentiles for those variables. So as I said before, process is not going to generate the results for you. You have to do it. You take this information and kind of do it yourself if you want a plot of that information. We'll scroll down. We'll look at rumination right here. And so with rumination, remember that we were looking at the effect of the mediator on the outcome as moderated by self-esteem. So there's the regression slope for the effect of the mediator when self-esteem is equal to 0. You can see that effect is statistically significant. You can see here's the effect for self-esteem when the mediator is actually equal to 0. And then we have the interaction term, and the regression slope is 0.0007. And you can see that that is not statistically significant. So in other words, the slope for the effect of upward social comparison on rumination does not appear to vary across levels of self-esteem. So there you go. So path B does not appear to be moderated. If we scroll down, you can see that those conditional effects that we were talking about previously are not showing up, and that's because the p-value for our interaction term is obviously above 0.20, so that's not going to show up. We do still get the data for visualizing conditional effect, but we're largely going to end up with, if we plot this out, the regression lines are largely going to be parallel to each other. If we scroll down a little bit further, you can see that we have, it says conditional indirect effects of X on Y. So the indirect effect is the effect of mindfulness on upward social comparison, which is predicting rumination. So there's our indirect effect, the mediator being upward social comparison right here. So now we have the effects, the indirect effects that are computed at each level of the moderator. Or at our 3 levels of the moderator. So at the 16th percentile of the moderator, the indirect effect is negative 0.2415. At the 50th percentile, it's negative 0.1379. And at the 84th percentile, it's negative 0.0599. We can test whether those indirect effects are statistically significant using the bootstrap confidence interval that's provided over here. So this is a percentile bootstrap confidence interval, 95% confidence interval. So we have the lower bound and the upper bound for each of those confidence intervals. So if 0 falls between the lower and the upper bound of a confidence interval, then that conditional indirect effect would not be significantly different from 0. But if 0 falls outside the lower and the upper bound, then we would deem that indirect effect statistically significant. So the indirect effect at the 16th percentile for self-esteem is negative 0.2415. The confidence interval ranges from negative 0.3974 to negative 0.1027. 0, which is the null, does not fall between the lower and the upper bound. So we would deem this effect right here to be statistically significant. If we look at the effect at the 50th percentile of self-esteem, then you can see again that our bootstrap confidence interval has both the lower and the upper bound are negative. So 0 obviously does not fall between the lower and the upper bound. So in that case, we would say that the indirect effect or the conditional indirect effect is statistically significant. When we look at the conditional indirect effect at the 84th percentile, we see that the lower bound estimate is negative 0.2. The upper bound estimate is 0.0787. So 0 does fall between the lower and the upper bound here. And so that conditional indirect effect would not be deemed as significantly different from 0. Now, it's important to keep in mind that that these indirect effects and their tests right here are not in and of themselves indicators of moderation of the indirect effect. All these are kind of are essentially kind of conditional indirect effects and associated significance tests, but they don't tell us about how the indirect effects are changing. So what we want to do is to kind of think in terms of, these indirect effects. You can see it's negative 0.2415 here, negative 0.1379, negative 0.059. So you can see these values are not all the same. And you can see that actually the values are becoming increasingly positive as we move from low self-esteem to higher self-esteem, higher self-esteem. But we don't have that quantification like we have in the case of of process models 7, 8, 14, and 15, where you would have the index of moderated mediation that would be indexing the linear change in those indirect effects. But what we do have is the pairwise contrast between conditional indirect effects. So you can see right here that we have effect 1, effect 2. So you can see that the values that are shown right here, these are just pairwise contrast. There's the first effect in that first row right here. The second effect is this one right here. So all we're doing is we're comparing taking the difference. So if we take minus 0.1379 and subtract minus 0.2415, the contrast estimate is 0.1036. So we end up with a positive contrast value right there. And we have a bootstrap test of that contrast. So if 0 falls between the lower and the upper bound for that contrast, then that would indicate that there's no difference between those two conditional indirect effects. If 0 falls outside of the lower and the upper bound, then that would be an indication that there is a difference. So in the case of our first contrast, you see that 0 falls between the lower and the upper bound. So basically, there's no statistical difference between these two conditional indirect effects. Then if we contrast the negative 0.0599 and the negative 0.2415, here's our contrast estimate right here, and you can see that 0 again falls between the lower and the upper bound for that estimate, or the 95% confidence interval, and so 0, because it falls between the lower and the upper bound, the difference between these two conditional indirect effects is not statistically significant. Now, if we look at the last one, though, negative 0.0599 and negative 0.1379, here you can see that 0 does fall outside of the 95% confidence interval. So in that case, the contrast basically between these two conditional indirect effects is statistically significant. And so what we're looking for, if we want to make a judgment about whether there is an indication of moderated mediation, all we're looking for is at least one of these contrast tests to be statistically significant. And that appears to be the case when we are comparing the slope essentially at the 50th, the conditional indirect effect at the 50th percentile and at the 84th percentile and at the 50th percentile right there. Okay, so that that kind of wraps up the main interpretation of our results right there. But we can also, as I said before, we can plot out those simple slopes, and I'll show you how to do that. So we have all the information we need in order to plot out the simple slopes. I'm only going to be focusing in on the first output for the first plot right here. So this is our data for visualizing the conditional effect of the focal predictor. So again, we're predicting the mediator right here. So to do this, what I'll do is I'm going to create a new data frame. I'm going to call it plot data 1, and then put in my assignment operator, less than followed by a hyphen, and then we're going to type in data period frame, and then we're going to type in the name of our first variable. We'll call it mindfulness right here, and set this equal to, and we have to use our list function. So we're going to type in C equals, and then I'm going to essentially type in the values from here all the way down to the bottom right here. So I'm going to pause this for a second while I add that in. Okay, so now it's added in, and so you can see we have to make sure that we have closed out that parenthesis right there. We'll type in a comma, and then we'll add in our next variable. So it is SE right here. So SE, and we're going to do the same thing for the second column. Okay, so now we've added that, and you can see we're closing that out again with the in parenthesis. Then we'll move on to our next line, and we're going to add in USC, and we'll set this equal to, use our list function, and then type in the values that are in this last column right here from top to bottom. Okay, so now I've added that in. And so again, we have to close out that parenthesis right there. And then we'll add a final end parenthesis to close out this first one right here. So there you go. So now what we'll do is we'll highlight all of this and click on run. And if you want to take a quick look at it, you can just type in plot data 1 right there and highlight run. And so there's our information. That's what was in our table previously. So now we'll use the interaction period plot function. So basically with this one, we'll type in interaction dot plot or period plot, and then we're going to type in the name of our data frame. So we'll type in plot data 1 $, and we're going to refer to our variable mindfulness first, comma, then plot data 1 $, and then we'll type in SE, then comma, and then I'm gonna go to the next line here and we'll type in plot. Oh, by the way, you got to make sure that you spell everything correctly. So plot data 1, and then $, and we'll type in USC right there. So at this point, assuming I haven't made any errors in my typing, we can highlight this and click on run, and you can see our output that's been generated in the panel on the right. You'll notice that the plot data 1 is showing up for the variable names, and that's just, basically that's just when we typed in plot data 1, then $, we follow that up with the variable that's referencing the data frame. So if we want to get rid of that part of it, one thing that we could do is actually use the attach function. So I was kind of messing around with this. We can type in attach, then refer to plot data 1. So we attach the data frame, and then I'm going to copy this and paste it in, so kind of reduce my typing. And then we can just refer to the variables in the data frame. So if I highlight all of this and click on run, and it looks like I forgot to get rid of that $, right there. So there we go. So we'll highlight this, click on run. And so now you can see in our figure, we have our variables without a reference to the name of the data frame. And then once we get done with that, we can detach the data frame. So I'll just use the detach function, plot data 1 right there to eliminate that from our workspace. Okay, so there you go. So that is pretty much going to wrap up this video presentation. Hopefully you found this useful. As you can see, there's a lot of nuances when it comes to running these types of analyses. But again, I hope you find this useful, and you guys have a great day.